Hey guys, welcome to my channel, and today we are going to discuss on interview questions on polymorphism. So I am expecting you to have some basic knowledge on polymorphism because we are going to focus more on the interview question. But let's start with the basic introduction. So what is polymorphism? Polymorphism is the ability of an object to take on many forms. So in Java, you have two types of polymorphism: compile time polymorphism, achieved through method overloading, where multiple methods in the same class have the same name but different parameter list. And the other one is the runtime polymorphism, that is achieved through method overriding, where a subclass provides a specific implementation of a method declared in its superclass. So let's begin with the interview questions. So generally in interview you get code related questions on polymorphism. So let's take a look at this code to understand the concept of covariant return type in Java. Now covariant return types allow an overriding method in a subclass to return a type that is a subclass of the return type declared in the overridden method. Let's get into the code. In this example, we have two classes A and B, where B extends A. The A class defines a method calculate with a return type of number. In class B, we override the calculate method, but here the return type is different. It's integer instead of number. Because integer is a subclass of number, this override is allowed. We can see there is no compile time error and it is running perfectly fine. This override is allowed under the rules of covariant return type. But what if we change the return type of the overridden method to suppose string? It won't be allowed because string is not the subclass of number. You can see that the return type is incompatible with the sub superclass return type, meaning the return type in the subclass method can be a subclass of the return type in the superclass. Now let's examine how access modifier work with the method overriding. When we override a method in the subclass, Java enforces certain rule around access modifier to maintain consistent visibility and accessibility. Now here we can see in our example that the class A calculate method is declared as protected. This means it is accessible within the same package and to subclasses but not to the world at large. But when we are overriding calculate in class B, we change the access modifier to public, making it accessible from any class. This is allowed because public is less restrictive access level than protected. So the method in B can be accessed more broadly than in the method in A. However, if we try to change it to private, Java throws a compile time error. This is because the overriding method cannot reduce the visibility of the method it overrides. So this is the visual representation of restrictiveness. Now in this example, let's discuss how exception handling works in method overriding, especially focusing on checked exception. So what do you expect the output to be? Because here in the parent class it is throwing an IO exception, while in the child class it is throwing a file not found exception. In this example, the child class, we override the perform task method. Here, instead of throwing IO exception, the child method throws file not found exception. This is allowed because file not found exception is a subclass of IO exception, and in Java, overriding method are permitted to throw either the same exception as the superclass exception. So if it is throwing an IO exception, that is allowed, or a more specific narrower subclass of the exception. This is known as the exceptional rule of overriding.
Now, if we change this exception to some other exception like class cast exception, this is not allowed because uh, this class cast exception is not the subclass of the IO exception. So in Java, overriding methods are permitted to throw either the same exception as the superclass method or a more specific, narrower subclass of that exception. Now, our next example is that of the static methods. So in Java, static methods belong to a class rather than the instance of the class. This means they are resolved at compile time, not runtime. So here we can see that we have uh, three objects. The first one is the parent, as well as the object is also parent. But in the third one, the reference type is of parent, but the uh, actual object is that of a child. When we are running this, we call parent to object dot display. This line 33, even though parent object 2 point to a static child instance, the static method display from static parent is called because static method, this happened because static methods are resolved based on the reference type, not the object type. So whatever would be the reference type, the method of that class would be called if it is static. So it doesn't, when you define a static method with the same name in the subclass, it doesn't actually override the method class static method. Instead, it's called method hiding. So we can conclude that static method cannot be overridden in a traditional sense because they belong to the class, not instance of the class. When you try to override a static method in the subclass, what actually happened is method hiding rather than polymorphism. Now, in this code, we explore the concept of upcasting and downcasting, which are common in Java when dealing with inheritance and polymorphism. Let's see the code. Now, this line number 24 is upcasting. What is upcasting? It refers to the casting of the subclass reference to the superclass type. This is safe and implicit because every instance of a subclass is also an instance of a superclass. So, but now downcasting, like this line number 29, what we are doing is we are explicitly downcasting my dog, this my dog object, which is of type animal, to dog, so that we can call the fetch method because fetch method is only belongs to the dog, not to the animal. And reference type is that of a animal. So if we are not doing the downcasting, we will get a compile time error since fetch is not a method in animal. Downcasting, but here what we are doing is we are downcasting this my dog to dog, and then if we are calling the fetch method, it will run perfectly fine. But downcasting can be risky because if my dog were not actually an instance of a dog, attempting to cast it would cause a class cast exception at runtime. To prevent this, this is the best practice code. To prevent this, it's a good practice to use an instance of operator. You can be asked some real-time example use where this polymorphism is used. So this is one example. Like in an e-commerce project, you might have a centralized payment process that dynamically select a payment method based on user choice. So it could be a credit card payment or the PayPal payment. By using a payment service interface, you can create an instance of any payment method at runtime and call process uh, payment without needing to know the specific type of payment method in advance. This is a great use case of polymorphism. Thanks for watching. If you found this explanation helpful, don't forget to like, subscribe, and hit the notification bell for more Java insights and interview tips. See you in the next video.